1, 2, 3.
Okay. So hello everybody, and welcome to today's class, which is Introduction to Set Theory. And for like a start, to like fully understand what exactly is set. So just imagine, like in our daily lives, we've actually had different applications of sets, from the set of students coming to the University of Lagos have a particular cutoff mark from JAMB, and that's an example of like a set. So we all know Spotify. On our Spotify, we have playlists whereby you've classified your songs to the genre you like. And that's also like an example of like set. Okay. So it's really interesting to see how set is like applies to like our daily life. And there's some times whereby your friend probably has a better music taste than you, and you want to enjoy the music they listen to. Then you told them to probably share it with you, and you can actually like listen to the music in their playlist. And that's how it like also happens, the different set theories we have. And that takes me to like a concept in sets, which is called that's a concept called union. Okay. And there are some times whereby you and your friend, you just like the same, you people have the same taste, as we say. And in the set theory, that's an example of like intersection. Okay. So you can just keep on like thinking about other examples of different, let's say, collections in your daily life in which there's actually sets. So a set is a collection of distinct objects, which can be anything. It could be numbers, letters, or even concepts. Okay. So we have different types of sets. We have the well-defined set, and we have the poorly defined set. And an example of a well-defined set is actually like numbers. So 1, 2, 3. As you're looking at the set, oh, it's well-defined. This is a set that has like numbers. ABC is a set of like letters. So that's like examples of like well-defined sets. Then we also have poorly defined sets, and that is an example is like tall people, because like height is not the same. And also beautiful cities. The way Lagos is beautiful is different from the beauty like Abuja has. Okay. And this is like an example of poorly defined set. So I'm going to share my screen. Okay, so I'm coming in on my video. Okay. Okay. So for those who have come across the whole concept of sets before, you would have seen something that looks like, let's say, A equals to, then curly brace, 1, 2, 3. And this literally means like 1 to 3 belongs to A. Okay. Then we also have empty sets, and that's literally like a set that has nothing in it. And that's an example of like empty set. So now to the different set operations that we have. Remember when I started, I talked about how, having the same taste, then that means you and your friend actually intersect. So that's the same thing, the same too here. So let's say we have, okay, our A equals 1, 2, 3. Then we have probably B, set B, that has, let's say 2, 3, 4, 5. I'll take this image. So the intersection of A and B, the intersection of A and B would be what is in A and also in B. So in this case, we have 2 in A, which is also present in B. So one of the intersections of A and B is 2. Then there's 3 in A. There's also 3 in B. So that means 3 is also like an intersection. There is 1 in A, but there isn't 1 in B. So 1 is not part of like the intersect. Then we also have the union. So an example of union, or in this case, union is literally like combined both of these things. That's like a union. Okay, so that's like a union. And in that case, that means A union B would be equals to, that means whatever is in A and also in B. So in this case, that would be 1, 2, 3. Then we come to B. We've written 2 before, so we don't have to write that again. 3, we don't have to write that again. Then 4. Then also 5. Okay, so that's a union, an example of a union. Then we also have the complement. We have the complement, and that is, I think it's in my screen. And that's literally a complement of A is any set that is in like a universal set. Oh, I skipped that. So we actually have something we call like universal set. And from the word universal, that means a whole. So the universal set has like all of these sets, the complete set. That's literally like, let's say, the universal set. So if you're saying a complement of A, and let's say a universal set, let the picture be U, is 1, 2, 3, 4, 5. Yes, I think we can do that. So a complement of A in this case would be whatever is not in A, but is actually like in the universal set. So A complement is, so we have 1 in A, and there's 1 obviously in the universal set, because like that's where like this order subsets like are picked from. So we have 1 in A, there's 1 in the universal set, 2 in A, there's 2 in the universal set, 3 in the universal set. Then we have 4 and 5, which is actually in the universal set, but it's not in A. So A complement is 4 and 5. Then B complement in this case would be just 1, because in our universal set, we have 2, 3, 4, 5, and there's also 2, 3, 4, 5 in our B, and the only number not there is 1. Okay. So then that brings the question, what about if there are actually 2 elements that do not have, if there are 2 sets that do not actually have common elements? So let's say let me use another example. So let's say probably like F is equals to 6, 7, 8. Then we have probably E. which is equivalent to, let's say, 9, 10. So if we ask to find probably the intersection between F and E, so in this case, there's actually nothing in common, as they're like all distinct. So in this case, we get an empty set. The intersection of F and E is actually an empty set. Okay. So I think that's it. Literally for like the set theory. Because I'm trying to like share my screen. So now that we've covered the basics, we are going to be going straight with answering some sets of questions. I'm trying to get this to load. So I'm able to like display the questions. Oh my God. I think I'll just continue the explanation while I wait for like this to come up with a set of questions. So we also have like other sets, and we have the power set. So the family of all subsets like of any set S is called the power set. And we denote it by 2 raised to power the power. So for example, let's say m equals this, then 2m is equals so these are the possible sets that could actually be formed from this AB. So it's either we have AB, or we have A, or we have just B, and sometimes even an empty set. So an empty set can also like be denoted like as this. And that's like literally it for that. So we also have the disjoint set. So if set A and B have no elements in common, if no element of A in B is in B, if no element of A is in B and no element of B is in A. So that's an example of a disjoint set, which I said yesterday, and it's represented like this. So then we have the Venn diagram. But this thing should come back. Okay, so yes, I think we're good to continue now. So next we have like the Venn diagram. And a Venn diagram is literally a way of like illustrating the relationship in sets, but now using like diagrams. And as you can see, like in this example, suppose we have A and B and say A is not equals B, then A and B can be described by either diagram like this. So suppose A and B are not comparable, then A and B can be represented by the diagram like and like this. So this A and then this B there. So let's say A equals A B C D and B equals C D E F. So looking at this, you would see there are some letters that are like similar. There's some letters in A, they are also like in B. And that's why we have them here in the middle. So this is literally the pictorial representation of sets that intersect the C and D here. Then the A and B are here because like they do not intersect. Um, so this is the continuation of like the Venn diagram. And the union of set A and B, like explained earlier, this is the pictorial representation. So it's all colored because like it's a union. I know a union is whatever like it's in A and like also in B, and this is what the pictorial representation of intersection looks like. And then we have like a difference, and this is what like it's also looks like. So I think that's like a good cover of all of those. Then we can actually head straight to solving questions, and I'll be sharing my screen that has like the questions be solving. So we'll be starting with like this set of questions. Oh, this is still live. Okay, so I'll just start with the solutions of the questions like I projected earlier. I'm so sorry for like hiccup. It's like being caused. Oh, and then the first question we had, 40% of our chemistry, 48% offered mathematics, and 15% offered both. So using Venn diagram to like explain that. Before that, let's first write out like the parameters. So let's denote like chemistry as C. So say C is chemistry. Now we can write this like this. So PC equals 40%. Because like 40% actually offered chemistry. Then we have 48% of the candidates who offered mathematics. So let's depict like math with M. P, 48%. And then we have those who offered both subjects. And that's like, let's probably depict that with sorry. So since there are two who offered both subjects, that's an intersection. And that's literally P C intersection M. Because like it's both who offered the percentage of both who offered this. That's 50% of students. And if we were to illustrate this like in a Venn diagram, then that would look like this is how this would look. So let's start by drawing our first circle. Then this is going to be our C. So that's like our chemistry. Then because there's a boat here, so that tells us there's some sort of intersection. So M, that's for like math. And then we know straight away that since both is offering like 15, so if 15 is here, and we have 40 who took chemistry, so that will be 40 minus 15, and that's like was literally going to give us the result of that of chemistry, because no 40% is the total who took it. So 40 minus 15 would give like 25%. And then mathematics, 48 people took it, 48% students took it. So 48 minus 15 would give 33% who offered mathematics. So if we would be getting those who offered either chemistry or math, then that means we need to find the union, because remember, union is like a combination. So P C union M is equals to 40 plus 48, 40 plus 48, then minus 15, which is like, because this 15 is like the intersection. So minus 15. And that's literally like 73%. Yes. 73%. So 73% of the students either offered like chemistry or mathematics. And if we are to calculate the percentage of students who offered neither of the subjects, that means they did not offer any of these subjects. That would be P equals. So because this is a percentage, that tells us like 100. It's like the total. So 100 minus the value of those who offered like either of both. That's 100 minus 73, which is equals to 27%. So the percentage of students who offered neither of the subject is 27%. So what's the next question? if X and Y are non-empty sets, then so if X and Y are non-empty sets, then the difference between the two sets X minus Y union Y minus X and X intersection Y is given by. So here we have to find a difference, the difference between. So we have to find the difference. So this is the next question now. The difference between X minus Y union Y minus X and X intersection Y is given. Is given. So to approach a question like this that has the difference is so X minus Y is equals to that means X is an element of this X, this big X here, this meant to make it capital X. X is an element of X, but X is not an element of Y. So like that's what this X minus Y means. And that's like the same to, let's say you have Y minus X. So let me just write this out. X is not an element of Y. So next, we want to set the let's say the symmetric difference, and that's literally like the union of X minus Y and Y minus X. Union of X minus Y and Y minus X. And that's like literally X minus Y, union Y minus X. And then next, the intersection literally is X minus Y, similar to like the union we have here. And if we want to analyze this union we have here, X minus Y union Y minus X, this is actually similar to X union Y minus X intersection Y. And if we want to analyze X intersection Y, in this case, that's like the set of elements that are common to both X and Y. So the difference between the two sets, X minus Y union Y minus X and X intersection Y, which is like the main question, is X minus Y union Y minus X minus X intersection Y. And if we observe this result, you notice that X minus Y union y minus x contains elements not common to like x and y, while x intersection y contains elements common to both sets. And the difference is like as simple as as simple as x minus y union y minus x, which is a symmetric difference, and the answer is like either because like they're similar, so x minus y, and in this case the correct option is actually like this. Okay, I think we can solve one more question. And that's literally the question that says the number of partition of the set 1, 2, 3, 4 into 3 subsets is. So these questions that I'm actually like reading off, they are like the questions that I shared initially. First question that I shared initially.
Yes, ma'am.
Okay, so the partition of 1, 2, 3, 4 into subsets. And literally the way partition.
I'm organizing tutorials for freshers. Freshers. I don't know where it's It's not even, it's in the bedroom, I think. Yes, I told him yesterday. Yesterday when they were doing the one that he said his phone was down. Yesterday.
So now in this case, for partitions, a very
So, being joined. It's in the bedroom.
That's good.
It was so finished, so
Let's go join.
we started since like 6. And I was on call with myself, and so I was just inside. I don't think it's even on their fresher group chat. I'll add him to the group. It's the fresher before it's my brother. He said we have to learn how to adapt to school and everything that will be. Because
Kò sí ìlú ẹni tí látẹ̀kọ̀. Tí mo kó ti ṣe tán. She has been in toilet. 7.
it's a tutorial, not a class. Ulssa tutorial.
I never got. Whenever informed of any traveling. When I informed.
Opportunity. This 1 year, don't advise it.
I said whenever informed. All the days that were on, we're not informed of any.
I've added it to the main threshold.
Who just added it? But then you're
His colleagues are yeah, I have his colleagues now on the threshold group chat.
ṣe bó ní platform tó yẹ kán ti sọ fún wọn tí wọn àdẹ sọ fún wọn
Ó dúró sí pé.
tó máa tójú bọ
The
platform
university to seek for information. Information will not look for you. This is when
ju wọn ẹ má jọ nílẹ̀ bẹ́ẹ̀ yẹn o
oh yeah. I think you're okay.
ẹ má jọ nílẹ̀ bẹ́ẹ̀ yẹn o.
Go to a very long one. Oh, okay. Oh, okay.
Ọ̀rẹ́ wọ̀
Go to office.
ṣe ti da nílẹ̀ gbogbo ẹ̀yìn yẹn ẹlọgbẹlọgba gbogbo bẹ̀rẹ̀ dry láti ìjọba ẹlọgbà ẹlọgbẹ ẹjọ.
Good evening, everybody. I'll be taking you to the Y111 Protozoa. My name is Adifalar. If you have any questions, I'm sure you'll be able to get to me. Let me try and share my screen. Just a moment, I'm trying to open the slide. while I'm still trying to get the slide that you'll be able to see it, I think I should be able to start with it. But the problem is you only be sharing. So I'll just be like briefly discussing it. I'm not sure if you guys have started your classes yet, but at least maybe you'll be able to. Okay, please go ahead. I can use that.
Make me an host on the call. Make me an host.
Okay, I've done that. Okay, yeah, this is the one I have. Thank you. Okay, so I'm hope you guys can see it. So the first point we have there says as per two kingdom classification, Protozoa was treated as a phylum under the animal kingdom. It was a phylum itself. We have kingdom, phylum, class, order, family, genus, and species. Before it was arranged properly, it was taken as a phylum on its own, that is phylum Protozoa. But after further classification, it was put under the kingdom Protista using the three kingdom classification proposed by Haku. So it then became a phylum under kingdom Protista. It was no longer just on its own. There are about 215,000 described species of protists, of which about 92,000 are protozoans. So out of that 215,000, we have 92,000 protozoans. One second. Protozoans themselves, they are like a basic definition that you can use is that they are single-celled eukaryotic microorganisms. Single-celled means they can exist as one cell. They don't need to come together. They can exist on their own. And then eukaryotic means that they have a nucleus and they are membrane bound. So they can stand on their own, basically. The first one that was observed was the Vorticella convallaria by Anton van Leeuwenhoek, which was about, I think, 17th century. Let me confirm for you. Yes, it was the 17th century. I'm just going to keep using this slide. Hope you guys can see it. The term itself, Protozoa, was coined by Goldfuss. And they included protozoan sponges, coelenterates, rotifers, and bryozoans. So the term protozoa, like, it was tagged for a group of organisms that contained all these classes on their own: protozoans, sponges, coelenterates, rotifers, and bryozoans. Before then, they were called animalcules by Anton van Leeuwenhoek. Before they were grouped as protozoans. Before then, they didn't have a name for them, so Anton van Leeuwenhoek used to call them animalcules, as in molecules, animalcules, most likely. Von Siebold restricted the name protozoa to apply to all unicellular forms of animal life. That is, he thought that it covered all unicellular forms of animal life. He was broadly generalizing it, you can put it like that. Say that then he thought all unicellular forms of animal life, that is, all anything that can exist as one cell as an animal was a protozoa. But based on where we are now, we know that that is not true. We have different classes and phylums. So the general characteristics that protozoans have, we've mentioned this, they are unicellular, they can exist on their own. But I might prefer to call them acellular because them as their own, they perform everything that normal organisms can partake. They perform all life activities, and it is functionally equal to the metazoan animal. That is, it is, if you look at it as an animal and look at it and you look at another animal, they can both carry out the same functions, like life activities, the respiration, the digestion, all of that. Division of labor occurs among various organelles of the cell. Okay, so they have these organelles are basically very small organs that perform specific functions in microorganisms. The same way we have kidneys, hearts, liver. Organisms don't have all of those because these are what we have are very well developed organs. So they have organelles, which are the small ones that they can accommodate. And those organelles all have different functions. Like from your biology, you should know that the mitochondria is the powerhouse of the cell, responsible for generating energy, responsible for like they all have their own functions. The nucleus is for housing DNA, things like that. The if you want to go back to as basic as it is, the cell wall protects the cell, also like that. They all have their own functions. Okay, next point. These may be solitary or colonial or free living even. Solitary means that you can either find them on their own as a standalone organism, like example Euglena, or you can find them as a colony, a group that has come together to exist as that group, a colony. Example is the Proterospongia. And free living means you can find them in any form, like in any environment. They can be found almost anywhere. Example is the amoeba. Okay, the next point. Symmetry. Symmetry is just how, like, if something can be divided into two, and those two are equal parts, then you can say it's symmetrical. So spherical symmetry means that if you cut it, both halves, both spheres, you can say that will be equal. That their two halves will be spherical in shape and they will be equal. Example is the Heliosant. We also have actinopodians, radiolarians, colosum. Now we have radial symmetry, those in sessile forms. If you cut them by their, how do I put this now? I'm looking for how simplify it. Okay, it basically means you can divide it into smaller halves along different points. Let's say now, you know how the radius of a circle can be picked at any point from its middle to its circumference. Like if you pick a point in any point from the middle of the organism and cut it to the end, it will be equal with the other side. It has a top and bottom, but it does not have left and right. So you can only take it from like the middle to the end. You can't cut it halfway like spherical symmetry. We also have some examples that are asymmetrical, that if you cut them in half, they won't be equal. That no matter how you want to do it, one side will either be bigger or different shape, like the lobose protozoans and the foraminifers. The next point. The body is naked or covered by pellicle or shell made of silica or calcium carbonate. Okay, so this pellicle is like a hard covering around the outer the outer membranes, and put it like that. It's flexible, but it's an outer covering to provide shape and protection. So that is what is responsible for their shape, and it keeps them safe from the external medium that they are found. It's usually made out of silica or calcium carbonate. Division of bodies at subcellular level. I guess you can say that if you were to look at how their body is, you can only divide it at a less than a cell because they are already cells on their own. If you divide them broadly, you won't be able to get it. If you do it like that now, they are. Sorry, I'm looking for how I'll get it. They are organisms that they don't have true cells. They are made up of like parts more than a complete cell. So if you want to classify them, they don't have any true cellular structure. So you can also see this in other acellular organisms that have simple structures. Since they also have simple structures, you can't really definitely define them. Their body division is at subcellular level. If you have any questions, I hope I'm sure you'll be able to. I'll be able to check them later. Hopefully, I'll be able to get back to you guys. Locomotion is brought about by locomotory organelles like flagella or flagella and cilia. Can you move this slide? I can't do. Cellular extensions like pseudopodia and some pellicular contractile structures like myelins. So the flagella is like a long extension from the outer part of the cell. It's like a tail, if you can think of it like that. Yes, that you know how fish use their own tail to move left to right, left to right. That motion propels the protozoan forward. Cilia is tiny hairs around the body structure that also move the cilia around its extracellular matrix. The extracellular matrix I've been talking about is like what you find it in. The same way you can find if I put a cell in water, then the water automatically becomes that cell extracellular matrix. But we can't always find them in water. So whichever environment you find them in, that is their extracellular matrix. But they're usually found in a form of fluid or the other. That fluid is their extracellular matrix. Pseudopodia. It's also a form of locomotion. It's like small. It's like cilia, but they are much smaller. They are not hair-like. These ones are thicker. They are like you can think of them as fingers in a way. They are thick. They are used to move around. Another word for them is false feet. So they are like they extend from the cytoplasm and they help the cell move around. Okay. Contractile structures like myelins. I think this is also for locomotion, but this one is not really same. It's more of like there are fibers found on it, but they change shape based on similar. So sorry. These ones dilate and contract to provide thrust, like to open and close sort of. Nutrition is holozoic, holophytic, or osmotrophic. This is their mode of thinking. This simply means that they don't create their own food. They are heterotrophs, which means they feed on other things that are produced not by them particularly. They use complex organic food materials. It's a form of steps. For the steps, I think let me just go through the steps briefly. They first ingest food, that is to absorb it into themselves. Enzymes within them will break it down, that is digestion. then the cell itself absorbs these nutrients, which are that's what the enzymes break them into. That's absorption. Assimilation is when the cell uses the said nutrients for growth and energy, bodily functions, like that. And then the one that is not used, the undigested waste, is expelled. That is their mode of feeding. They don't produce their own food by themselves. They are holozoic or holophysic or trophic. Digestion is intracellular. Okay, this is also part of feeding. It means that digestion takes place within the cell. They take their food in, they digest it within their cell, and then they use the broken down nutrient. Next point is contractile vacuoles, which are common in freshwater forms mainly, except for osmoregulation. Okay, so from biology we should know osmoregulation is just maintaining the internal water and salt contents of the body. It's like a way of making sure there's not too much water and there's not too little water. So contractile vacuoles are like specialized holes found on the protozoa. They either push out excess water or help take in more water. They are common in freshwater forms mainly. Mostly the protozoans that you find in freshwater, they will most likely have it. That is their most common protozoan. Asexual reproduction by binary or multiple fissions or plasmotomy or budding. Okay, asexual reproduction, we should know that it means without both female sexes or gametes being present, they can still reproduce. They don't need the other. They can produce and reproduce on their own. Binary fission is simply division of the cell into two daughter cells, which are both a clone of the original cell, the parent cell. So imagine I think I can use egg roll to describe it. If I cut an egg roll in half, it will be two halves, but for the cell, the two halves will form two new egg rolls that are the same as the original egg roll. If it helps you understand, multiple fission just means into more than two. Let's say some cells divide into like it just continues. That multiple fission is just continuous binary fission. Instead of two, those two will also divide, and so on and so forth. I think that's the ones that form colonies on their own. Plasmotomy or budding. Budding is when a part of the parent cell breaks off and forms its own cell. It becomes an individual cell. So imagine I took parts of somebody's. Imagine I took a finger now, and from that finger, another human being is formed. I guess you can use that. Imagine a piece of the cell is removed, and that piece forms its own parent cell. This plasmotomy is just like it's the same thing as it's also division, but it does not require the nucleus to divide. Those new, like the daughter cells, will retain multiple nuclei from the parent. Like there is no division of the nuclei. It's distributed between the daughter cells. It doesn't divide to form another one. It just separates itself and distributes it between the daughter cells. The difference is normally when one divides, it can still retain its nucleus. This one, the parent cell gives its nucleus to the daughter cells without division. It just distributes them accordingly. It's also asexual reproduction, but it does not require nuclear division. The next slide, sexual reproduction by syngamy or conjugation. Okay, so this one is sexual reproduction. So the two protozoans will come together to reproduce. So this one requires both parents. It cannot happen on its own. Syngamy is where the gametes fuse to form one. Like imagine when they are distributed, they form half gametes, like haploid gametes. those are like, imagine a it goes down to their chromosomes, but it's really like half of a gamete on its own, but they can exist like that. So two of those halves come together to form a diploid zygote, which is all those n plus n, 2n, all of that. That's what we're talking about. Diploid zygote. It's this one is one of the most common syngamy. So the both of them combine their genetic material, and this produces a fertilized egg. So after the fusion, the daughter cell, which is the zygote, now has a complete set of chromosomes. Those haploid gametes have half chromosomes. So that 23 plus 23 forming 46. Yes, the zygote now has 46. It happens in, like, for example, chlamydomonas exhibits such reproduction. That is syngamy. Conjugation is where genetic material is exchanged. They just exchange. Imagine I have A and someone has B. We just exchange that, but they do not fuse. They come in close contact and they exchange, usually through a structure that they will produce on their own. They come together. It is formed like a bridge or a tube. A zygote is not formed, but it allows them to switch their genetics, which, like, in a way produces a new cell. So it does not. All of them don't have the same chromosome, so it improves diversity of the cell. Example that performs this is also Euglena paramecium phenomenon. The next point is to say encystment. Okay, they normally don't do this. The sexual reproduction is usually like a backup plan. They mostly favor asexual reproduction. So them choosing to wait out the unfavorable conditions is where it is much harder to perform the asexual reproduction. Where it becomes unfavorable, I think that is just basic English. So is not like the situation that they are in is not good, so to speak. So them waiting it out, that is the tide over. Like, choosing to struggle through it is encystment. That phenomenon to tide over unfavorable conditions. So motoplasm and claims power not differentiated. Okay. Let's go to their classification, please. B.M. Honigberg and others classified phylum Protozoa into 4 subphyla: Sarcomasticophora, Sporozoa, Nidospora, and Celiophora. These are I think this is divided based on their form of locomotion, actually. But let's dive into it. Okay, so we have subphylum 1, Sarcomasticophora. It's characterized by the presence of pseudopodia or flagella for locomotion. So these ones either have those false feet or they have that singular tail for locomotion. Under this subphylum, we have a superclass, which is a group of classes. It is like between phylum and class, but you can't really put as a class on its own, so we call it superclass. Mastigophora, Opalminata, and Sarcodina. So this only okay, let's go. Superclass Mastigophora. The body is covered by pellicle. That is that hard shell we discussed before, flexible, thin shell that protects the protozoa. And its locomotory organelles are flagella. This one is strictly flagella, used to move around. Asexual reproduction by longitudinal binary fusion is also binary fusion, but that longitudinal just shows us how it is divided. So now let's see up and down, left and right. From top to bottom, left to right. Longitudinal means north to south, up to down. And latitudinal is left to right. I think that one in biology, we call it lateral. Or lateral. It includes 2 classes, Phytomasticophone and Zoomasticophora. Okay. Under that Masticophora, we still have Phytomasticophora and Zoomasticophora. Okay, let's take those. Under Phytomasticophora, we have some are chlorophyll-bearing chloroplasts. Nutrition is holophytic, and reserved food is paramylum, includes eugenol. Okay, I think this is the These ones have more plant-like features. Chlorophyll, berry, chloroplast. I think that's why they're under Phytomastigophora. Nutrition is holophytic. This is also, I want to clarify this. Holophytes and Xerophytes and all of that. Okay, holophytic, they produce their own food. So these holophytes now is basically like this is the plant. It shares more of plant characteristics. So these ones are holophytic. They have chlorophyll, and they are bearing chloroplast. I'm not sure if this is spelled properly. The best food is paramylum. Or I'm sure you can check that out. Examples of Phytomastigophora are euglenoids and dinoflagellates. Examples are dinoflagellates, Serratium, like specifically, Serratium is a dinoflagellate, Noctiluca is a dinoflagellate without chloroplast, euglena. Dinoflagellates with chloroplast are Serratium, and Noctiluca don't have chloroplast. Those are dinoflagellates without chloroplast. So Mastigophora, I think this is the animal like form, mostly parasitic, chloroplast is absent, nutrition is holozoic. Okay, so holozoic feed on what they don't produce their own food by themselves. Mostly parasitic. Parasitic is they depend on a host to feed for sustenance, usually causing harm to the host. So they feed on or they feed from another organism. They don't have chloroplast and they are unable to make their own food by themselves. That's the first line. Fibrotic or parasitic. Yeah, parasite is still that's a parasitic. Reserve food is glycogen or volutin. Okay, glycogen is how that is what they store their food as. And examples are trichomonas and trichonim mutualistic. I think when this trichonim isn't really we can't really say it causes harm because they put in bracket mutualistic. So I think it's both ways. And then leishmania. When you are going through it, I'm sure you can find other examples if these ones will be hard for you for these verses. Yes, maybe you should just try and get ones that you'll be able to understand better and be able to remember because spelling is very important. Okay, so remember we left superclass Mastigophora. That was where we found Phytomastigophora and Zoomastigophora. Now we're going to superclass Opalinata. All of this is still under subphylum Sarcomastigophora. So it might look very like a lot of words like that, but if you can, I would suggest you use like a red biro or something when you're writing it out. You draw your own table that will help you understand it. So you know which one goes under which one. So you won't confuse it because it's very easy to model it up. All these Mastigophora. Okay, so going to superclass of Palinata, we have commensals or parasites in the gut of anurans. Okay, so commensals are like they also they are not parasites. They have their own benefits to the host. They are symbiotic. It's a symbiotic relationship. It's either one is benefit, only one benefit. Sorry, they don't have benefits to the host. It's only them that benefit, but they don't cause harm to the host. They can also be parasitic, which means that these parasites always cause they will have one form of dismerit to the host. So in the gut of anurans are like amphibians. They don't have tails. That's usually what we've been used to know anurans. They don't have tails. So like frogs, toads, things like that. That's where you mostly find them. Body is covered by oblique rows of cellula, but without superciliary system. Okay, so that means that their body is covered by cilia, which we discussed before, which are those like small hair-like protrusions from the helicle that are used for locomotion and feeding. But they don't have infraciliary system. This infraciliary system is like a structural network used to coordinate the movement of cilia. So I'm thinking if they don't have something that coordinates their movement, I'm sure that means the cilia is just to help them move. But they are not in full they're not in full control of this cilia. Some are binulate, while others are multinucleate but homokaryotic. That is, the nuclei are identical. Okay, so some have more than one nucleus. I think that's what binucleate means. Yeah, some have more than one nucleus. But and others can have, like, binucleate is two nuclei, and multinucleate are more than one nuclei. So, but they are always homokaryotic. That is, they always have the same type of nuclei. There's no difference. The nuclei are the same, identical. Asexual reproduction by longitudinal binary fission, the same thing. The organism splits from top to bottom to form two daughter cells, and plasmotomy, discuss plasmotomy. This is the one that the nuclei is not divided, but it is distributed between the two daughter cells. Sexual reproduction is syngamy with flagellated gametes. Okay, syngamy is the one where they come together and the gametes fuse. So before the gametes can meet each other, I think that's where the flagella that is written here comes in. That's what they use to get to each other, flagellated gametes. Examples like Opalina and Zelleriella. So you can see that Opalina is an example under Opalinata. So maybe that will help you remember where it falls under. Then moving on to the next superclass under subphylum Sarcomastigophora, which is Sarcodina. Locomotion is brought about by pseudopodia. These are those finger-like structures that are found on the pellicle, and we also know them as false feet. This superclass now has its own three classes: Rhizopodia, Prioplasmia, and Actinopodia. So let's start with Rhizopodia. Or should I stop so we can get questions? In case I'm not sure, I can't really, in case there are questions. Let me give Sarayadi some time to see the message. When it comes online, I'll take a break then so that we won't waste time. Let's start with Rhizopodia.
I'm here with you.
I was asking if there are any questions I can take, or it's an after the class type of thing.
No, just continue after the class.
Okay,
You have just 10 more minutes. So.
Let me try and finish this subphylum 1. Then, if there's still time, I'll use that for the question. So,
Okay.
Rhizopodia. This one includes amoebas, foraminiferations, and mycetozoans. The amoebas have lobopodia, philopodia, pseudopodia. So, also explain this lobopodia. Lobopodia, philopodia, and reticulopodia. So these are types of pseudopodia. This one is lobopodia is this ones extend from the cytoplasm. They are blunt finger-like. These ones are the basic form of pseudopodia. I'm moving to the other one. So, philopodia. These are specialized types. These ones are special types. Philopodia they are thinner than the other lobopodia, but they are all pseudopodia. Like they are all used to move around. They all use pseudopodia to move around. But philopodia they are thinner and they contain actin filaments made of actin for support. Actin is a what's the word now? So then they contain actin for support. Actin is a substance. While the reticulopodia These ones they form a net shape. They are interconnected. So it's more like a web for trapping prey. They're all used for they're all used for movement, but this reticulopodia is the slowest form, but it's also used for capturing prey and helps to anchor the organism in the environment. So for foraminiferans have that reticulopodia, and amoebas can either have leucopodia or philopodia, or they can have both. In amoebas, the body is naked. It's either they don't have that pellicle or shell. Examples are the amoeba or entamoeba, or they are covered by a test, which is acera. Let me see if I can get. Let me continue. Let me continue because of time. Foraminiferans have a calcareous pore shell. Okay, that calcareous means that it is made up of calcium. Porous means there are holes surrounding it, that all over the body you find holes. And then the calcareous shells of dead individuals form foraminiferan ooze. I think that ooze is like where you find them, their own extracellular matrix. But it's made up of the calcareous shells of dead, the other foraminiferans. It is made up like, so a foraminiferan, if it dies now, the calcareous shell is broken down to form foraminiferan ooze. It's a form of sediment that it grows over time and sinks to the bottom of these ones are usually marine, so it sinks to the bottom of the ocean floor, something like that. Examples like Ophidium, Tharium, Dictyostelium. These ones, Ophidium are foraminiferans, you should be able to see that. Let me keep going. Plus Pyroplasmia. They are parasitic, they don't have any locomotory structure, and they don't have spores. Okay, parasitic, they rely on a host for their sustenance, causing onto the host. They don't have any locomotory structures, they don't have cilia, they don't have flagella, they don't have pseudopodia, and then they don't have any spores. They don't use spores. Example is the Babesia, which causes red water fever in cattle. Actinopodia, these are ray-footed protozoans. Let me try and explain that. Ray-footed protozoans are like it's a group of protozoans that they are also called actinopods. They have this like ray-like pseudopodia, which are like long, very thin, and they're supported by microtubules. Locomotion structures are axopodia. That is the ray-like extension. Those is a form of pseudopodia, but these ones are ray-like. Skeleton consists of silicous shell. Radiolaria. Silicous is, you can get that from silica. So their shell, which is called the radiolaria, is made up of silica or strontium sulfate spines. That one is acantharia. So if it is silicous shell, it is radiolaria, and if it is strontium sulfate spines, acantharia. Or radiating needles, which is heliozoa. Serious shells of radiolarians form ooze. Okay, so you know how the calcareous shells of the rhizopodia form from parent ooze. This one, the silicous shells of radiolarians form ooze, which is, I'm sure they have similar features, but this one is made of silica and it's for radiolarians. Examples like Colozoa, Actinophoris, and Acanthometra. Acanthometra is that strontium sulfate spines. Actinophoris is radiating needles, and Colosome is the silicous shells. So because of time, I think I'll be able to stop here. I don't want to start a topic that I'll be able to finish. So maybe in your next class we'll start with subphylum number 2, which will take Sporozoa or Apicomplexa.
All right, Oshaba, thank you very much for the class. I think we'll be stopping here for today. So the questions, I'll compile them in a Google Drive and then it's probably send them to you.
Okay, no problem. Thank you.
All right. Thank you very much.